So let's talk about decarbonisation. There is a pressure, as we just were discussing just before, to decarbonize oil, gas, cement, and other heavy industries. This pressure is for, of course, environmental issues, but also for some like economic development and economic issues. So we are talking about here the business models and how this can be escalated and how it can be deployed into not only in cement, but in different heavy industries. So I will be asking questions, but please feel free to participate and have it like a more like a chat and rather than me being the one who like moderate everything, even though I'm the moderator. So I will start with you, Ita. Let's talk about the role of CCUS in the net zero economy in a more general perspective.
Thank you so much. It's a real pleasure to be here with you. So it sounds, many of the themes were just brought up in the fireside chat, but at the Energy Transitions Commission, we've really spent quite a lot of time looking at the role of CCUS in a net zero economy alongside alternative kind of vectors for decarbonisation, so clean power, clean hydrogen, sustainable bioresources, carbon removals, etc. And our conclusion was really very simple. CCUS is vital but limited. So it's not a substitute for electrification, and it's not a license to delay action elsewhere. But if we are serious about net zero, it's also not optional. And to kind of support that, I'd make 3 points. So the first is, even with very aggressive electrifications, molecules won't disappear from our energy system. So the IEA, the International Energy Agency, in their latest net zero pathway, they thought electricity use could rise from about 20% today to about 50% of final energy demand being consumed as electricity by mid-century. And at the ETC, we're actually even more ambitious than that. We think you could push it even further, and perhaps even 65 to 70% of your final energy demand could be met by electricity in a net zero economy. So electrons really are doing most of the work. That's why it is a limited role, but crucially, they can't do all of the work. Therefore, it is still vital. And the remaining needs aren't marginal. We've obviously just heard about, the cement. They are concentrated in heavy industry and long distance transport. It's cement where it's a process emission. It's intrinsic to the production of the cement. It's chemicals where carbon is a feedstock. It's aviation and shipping where we can't electrify just due to the energy density constraints. So, when you're talking about then potentially producing synthetic fuels if you want to fully decarbonise those sectors, and carbon capture would be crucial to that. So from our perspective, you can't really paint a picture of a net zero economy without CCUS, because we can't assume that we'll have an economy where we don't use huge amounts of cement. It's crucial for our kind of global living standards. We can't really imagine that we're going to walk away from global trade or from like long haul transport. So I guess if we boil it down for us, and this is quite challenging, right, in terms of debates about CCUS, there are some that would really push, let's not go there, they worry about the moral hazard, and they worry about carbon capture and storage being used to delay action. And I guess for us, we acknowledge that. We don't think we do think this is a both, not an either or. But CCUS, net zero without CCUS, we would say, is not an ambitious pathway. It's actually just mathematically inconsistent.
Okay. Yeah, and just mention, even though the role of CCUS it is limited, because you will have a lot of that part of the economies that are going to be electrified anyways, as we just discussed with cement, but also with aviation. That rest is very relevant in terms of like emissions. We're talking about like a big chunk of global emissions that needs to be.
It's absolutely very, very relevant. Also, the thing to note when you're talking about this, again, when you say vital but limited, given where we are today, even this limited role is a massive scale up for the industry. So from an actual CCUS perspective, it is a scale up story. It is a massive growth story. It's just that massive growth story is alongside an even bigger growth story, which is growing our zero carbon power system of the future.
Let me ask you, Max, about how this is seen, and this urgency and this important role of the CCUS industry is seen from a capital allocation perspective. Is it still treated as something experimental, or is it becoming more like a structural investment?
Yeah, great to be here. Just to give you some context, we're an early stage decarbonisation fund, a venture capital fund that invests into breakthrough catalytic technologies that can reduce our emissions at scale. When looking at carbon capture, utilisation and storage from an investor's perspective, from a VC perspective, I think many VC investors do recognise its importance. We're way behind, I think, on deployment. I think we're at around 1% of deployed capacity to meet our net zero targets, our 2050 targets. So there's a lot of work to be done. That being said, however, it really depends on the investor how carbon capture and utilisation and storage is perceived. I would say there are lots of different types of technologies that fall underneath this umbrella term of CCUS. So there's been a lot of positive momentum in direct air capture. That being said, over the last year or so, the momentum in the space has faded a bit, but the macroeconomic factors accounting for this. Also, a lot of distraction from new technology areas such as AI. So I'd say there are several promising companies, direct air capture companies out there that are in the process of being scaled. I'd say in the space of utilisation and storage, a lot of investors think more conservatively. I think they believe that industry is largely responsible for implementing these technologies, as a large share of these technologies are somewhat de-risked and do not fit the classical venture timeline and exit model. We at Zero Carbon are now having a little rethink. We too were initially, I think, opposed to investing in carbon capture, point source carbon capture startups, because we felt like the capital that we had was better invested in, let's say, new foundational technologies that will completely reshape, redefine how steel, cement, chemicals are produced. But we've also reached the conclusion that the world is moving at a slower pace than desired, and that I think to avoid some of the worst long-term consequences of climate change, we do need to invest in carbon capture technologies now. So what we're looking for essentially are technologies that are really differentiated in terms of technology itself, but also in terms of the costs it brings about for the end user. And so I think there's some work to be done in the innovation space to bring down the costs of carbon capture. So it is necessary, and I think it is structural to a certain extent. But I do think that a lot of early stage investors right now prefer to invest in other areas. There's a lot of capital flowing into AI right now, despite the imminent importance of bringing down our CO2 levels.
Yeah, AI is drying everything up. But someone who got an investment is Andy here. And so we're going to talk about that. Just before the panel, I was making the comment that how since I started looking at energy issues more than 10 years ago, CCS was already in the conversation, and there is this public perception that it hasn't moved that much, but you have a project like this up and running. So I wanted to ask you, what was that tip, or how do you achieve this tipping the project for something from a project to something that was bankable, and you have investment and it is up and running, and which suggestion you will give to Max in order to increase the capital allocation to that?
Yeah. Okay. So my company Encyclis, we build and operate energy from waste plants. So we take rubbish, household waste, which can't be recycled, and instead of putting it into a landfill, we put it into an energy recovery facility. So we combust the waste, generate baseload energy from it, recover any metals that were still in there in the waste. They should have been recycled, but sometimes there are metals there, and then the ash gets turned into an aggregate. So it's already a pretty circular, pretty sustainable proposition. But there's carbon in the waste. We combust the waste. We emit CO2, and we're one of those. Very much like cement, there's nothing we can do about that. 1% of our Scope 1 emissions are within our control. 99% of it is there's carbon in the waste. The only thing we can do to decarbonise is carbon capture. So we've got a carbon capture project away up in the northwest, Protos. It would be the first commissioning emitter for HyNet. 2 clusters the government's bringing forward, one on the west coast, one on the east coast. Protos means first, so weren't we clever and prescient in naming our energy from waste plant? Not at all. It was called like, because the site is called Protos. We just took the name and the energy from waste plant was built. And why did we get away first? As with many things, it's a mixture of serendipity, tenacity, creativity. So the serendipity was we were lucky enough to build an energy from waste plant slap bang on top of the proposed HyNet pipeline. So we were really close. That helped. Four other energy from waste companies also had plants which were close by, and they could have done it. Why did we get there? And I think that's where the tenacity and the creativity comes in. So another bit of serendipity. A decade ago, I was involved in the last time the UK tried to get carbon capture away, as were lots of other people. And my chief exec was as well. So we had that kind of experience. I lost a year of my life to carbon capture a decade ago. I thought I was never going to get it back, and got the joy of doing it all again for 3 more years. So maybe that was part of it. And the company we were in at that time, the chairman's motto was determination, patience, perseverance, which in my thesaurus are all synonyms for the same thing. Never give in. So maybe it was a mixture of all of those things. And I think the big thing, the technology we're using is pretty basic. It's amines, very basic technology. Amines sounds like ammonia. Ammonia, 1 nitrogen, 3 hydrogens. Change 1 or more of those hydrogens to anything else, like a methyl group. That's an amine. Thousands of different types. They all have one common property. If they're in liquid form and you bubble air through them, the amines grab hold of the CO2. So the air that comes through is decarbonised. Then you warm the amine up and it lets it go. So it just catches and releases by controlling the temperature. It goes around. That's what we do. It's not new technology. It's been around for decades. My daughter's boyfriend is in the Royal Navy on nuclear submarines, and I spoke to him recently. I showed him our capture plant, and so that's where it is. And he said, "Oh yeah, how do you capture the CO2?" So, well, we use amines. So we do that on the submarine. It's like, really, you use amines on the submarine? They've been doing it for 50 years. So the technology is not new. The bit which is new is the business models and the financing and all of the contracting. That was the real first of a kind challenge. And credit to DESNET, they've learned from the mistakes of 10 years ago. Two different energy names ago. It was DEC 10 years ago, but they've learned some of the lessons and put in place some business models which were very rough and ready and were not deliverable or bankable when we picked them up. And it was 3 years of really hard work to get them there. But we've got 2 TNS transport and storage companies away and 3 emitter projects away, all with financing. So we've managed to get them where we've created that platform and that benchmark now that others can follow. Really hard work. These are big and complicated projects. They're still not easy, but we've created something to build from.
That's perfect. And I want to continue on the business model, that was what tip in order to get investment. And I wanted to go to you, Rich, that you also have you in fact you have the first obtained FID in CCUS in the UK. So what was that convinced lenders that there was an investable project, and was also the business model, was the infrastructure itself?
So for those who don't know, Northern Endurance Partnership, we are the CO2 transportation and storage company for the East Coast cluster, which is currently operating out of Teesside. And we have aspirations to expand that also to Humber. But yes, you're right. In December 24, we took the first FID along with our first capture project client, NZT Power. Fully support what Andy just mentioned, that the real trick in this is not technology. The real trick is how does this capture project and transport and storage co all fit together. And what I've said in other sort of conferences like this is that actually making that happen was an Herculean effort. to lift everybody at the same time. So that's capture projects, transport and storage companies, regulators, financiers, insurers, academia, government, all had to be on page at the same time. That took an awful lot of patience or determination and discipline, whatever your former boss said, and quite some risk taking, I think, to get it over the line. But to bring it to the sort of project finance element, NEP and NZT together were the world's first project financed CCS project at scale. And we have a consortium of 20 plus banks actually working with us on this. It was all about really understanding where is risk allocated and who is responsible for what risk. And crucially, in a world where carbon prices are only so high and currently the cost of doing this is higher, government subsidy has to come in. And so where is that government subsidy coming in? And how can investors see a sort of a guaranteed line of sight to getting return on their investment? A couple of crucial roles that the government play from our perspective as the TNESCO is the interaction between TNESCO and capture projects is what's known as cross-chain risk. So when one part of the chain doesn't work, who compensates the other part of the chain? And that's where government steps in through various mechanisms to allow this whole cluster to come up and take FID together. And the second thing is more storage related in the very low probability but high impact case that you have a large CO2 breach from the reservoir. Who is responsible for that? And again, that's where government, if you like, is the insurer of last resort. But in order to make that happen, for instance, another example of what this generated was before this all happened, there wasn't a UK industry in CO2 leakage insurance. And now there is. So a whole new stream of activity has been created, which I know that the brokers that we dealt with are now talking to other countries about exporting our learnings. So it really comes down to understanding of risk and allocating that to the right places.
Perfect. I really like that point of like now an insurance industry being created to allocate to satisfy this need, which is how it is like the clusters are evolving and the associated industries are adapting to this new or incoming technology that we have, because it's not that new as you just mentioned. On that, let me come back to you, Ed, and ask you. Let's continue talking about clusters and synergies. And I wanted to ask you, like, which synergies have you created, or are you creating with other industries and other players of the?
Yeah, it's a really interesting dynamic because our capture plants, our 4 capture plants, are collaborating on carbon capture and storage. But in all other respects, they are fierce competitors, right? So those relationships are really quite interesting, as you might imagine. But in terms of the synergies, I mean, it comes back a little bit to some of Rich's points. By bringing them together early on, you're able to significantly reduce many of those cross-chain, full-chain risks. So for us, for one individual cement plant to kind of stand up a pipeline and a store is just not credible, right? Because there's not enough volume, there's not enough certainty, there's too much risk, too much volatility. When you start to bring a number together, 4, you don't necessarily need all 4, but together you're able to provide a launch customer, to provide the infrastructure that then makes it much easier for everybody else. So it has its drawbacks, but bringing everyone together into a cluster to manage these risks to start with, it is a significant bonus. So those synergies are probably the most important for us to start with, because it's about getting to volume. And once you've got it in place, it all starts to get cheaper.
Okay.
The cost of abatement drops quite quickly once you have the infrastructure there.
That's brilliant, because it really leads me to my next question, which was great. But before that, may I ask the person who is managing the screen, to come back to the timer, because I only see the questions and I have this tendency to keep asking questions forever. So I want to keep sure that I stop talking at some point. So Ida, I'm going to you. So the CCUS economics, they haven't followed the dramatic cost of the dramatic reduction on capital cost that we have seen in other clean tech, like for example solar. I know it's extremely incredibly cheaper than it was 20 years ago. This hasn't happened, or at least not I'm aware of, in the CCUS industry. So I wanted to ask you why and how the industry can dramatically reduce the cost in order to become more. I mean, it's not that it competes against solar, but in order to reduce costs.
Absolutely. I quite like, when we talk about this question, I always quite like to start with a comparison that often surprises people. So back in 2008, the UK set up the Climate Change Committee for the first time, advising the government on how to deliver the carbon budgets it needed to fulfil the Climate Change Act. And when the UK CCC first looked at the costs of the technologies, it forecasted out what it expected from different decarbonisation technologies, and it expected both solar and carbon capture and storage would see cost reductions of about 25% over the coming decade. In reality, solar costs fell by 99%. And early CCUS projects actually came in more expensive than the costs that they had at that time. So why is that? And it really isn't a comment on effort or ambition. And I think listening to the people that we've heard on the panel today, you can really understand the effort and ambition that has gone on to delivering the CCUS projects we've got. It's actually about fundamentally different economics of the underlying technology. So solar is highly standardized. It's manufactured at bulk, at scale with near identical units. So it benefits from these really powerful learning curve effects and economies of scale. Once you start building, the costs fall out as you make that process ever more efficient in the factories. Many CCUS deployments are actually the opposite of that. It's often bespoke, it's often site specific. Every project, you have to look at the industries that are actually there, the different gas streams that you're capturing, the different distances to storage, what we've heard about today, the different geologies that you're injecting into. So much of the cost actually sits in that custom engineering rather than a kind of repeatable manufacturing model. And so it doesn't face those same learning curve declines that we've seen kind of driving solar down. So really expecting CCUS to behave as solar is kind of really a category error. It's not the right way to think about that technology. So what does this mean? First of all, I think it does mean, and this is why when I said, we see electrification as the core, the beating heart of the transition, CCUS is probably not going to be, in most instances, the cheapest way of decarbonising where there are alternatives. The point is, there are places where there aren't alternatives. So given that that's the case, we still have to look at really what we can do about CCUS. The second thing is that if we are thinking about how we can reduce the costs, what we need to think about, rather than a kind of standard technology that we continually drive down, here we're talking about how can we think about optimizing the system to minimize the costs of that project. So it's more of a system optimization, a coordination optimization, which I think we've heard great examples of how that's happened. So first of all, some big pieces we see. Hub and cluster models are obviously critical. We've heard already today why that's so important. You get multiple point sources to get it together using the same shared infrastructure, hugely decreases the cost. Also, pipelines hugely decrease the cost, versus the other alternative is often, shipping condensed carbon dioxide around. That is a lot more expensive. So pipelines help, clusters help. Second, the sequencing problem, and this is really often the challenge, going early to give yourself time to get through all those process hurdles. If you try and come in late and say we need this tomorrow, that makes it even harder to get all those coordination pieces lined up. So actually having those longer planning periods really help. And the third is really using policy to work as a system, which I think you have already kind of touched on. For us, when we look at how to make the business case stack up, you're talking about 4 different things kind of moving together. You're trying to see some kind of carbon pricing to create a level playing field. You're trying to see some kind of mandate or to push towards consumption of a kind of decarbonised product and bridge that green premium. We're looking for long-term contracts, which is often really challenging. But from the point of view of bankable project, if you don't have the long-term certainty, that's really difficult to get the business case. And then it's this shared transport and infrastructure at the same time coming together. So if you miss any one of those elements, most likely the whole project is going to fall, and the costs, as soon as the project falls or even is delayed and pushed back, the costs creeping up.
Yeah. On that sense, what you just mentioned, probably the comparison between CCUS and solar wasn't correct, and it was probably unfair to CCUS. I'm thinking about it could be compared a little bit more to nuclear. That is a technology that, even though costs of nuclear they haven't declined and now they cannot compete to solar, it still is a key technology for many other characteristics and many other advantages that nuclear has, and governments are still very keen to at least say they're going to invest on nuclear, even though the cost of nuclear haven't declined significantly in the past 30 years. But you also mentioned CO2 prices and how they are important to create this even field for all the industry to compete. And that leads me to you, Max, which I wanted to ask you, under current prices or for carbon, which industries does CCUS make sense, and under the projected carbon prices are expected to increase, which industries do you will see coming into the field?
So CCUS in general is not a cheap technology. Depending on the industry and use case, I would say it costs between 50 and 200 euros per ton of CO2, according to a recent BCG study. That being said, there are some low-hanging fruits where CCUS can be implemented effectively, even at the current price of carbon, which on the ETS is around 70 euros per ton. So I'm talking about ammonia generation, certain processes in the chemical industry, both of which produce CO2 in meaningful quantities at high purities. I think those are the use cases where CCUS can have its first moments of success. I think in the space of ammonia, there are already a couple of very large projects being brought online in the coming years, from 2026 to 2030. So that's definitely one of the areas where it can be implemented. I think the rest will definitely depend on how policy is being implemented. So we've got the ETS and the CBAM in Europe. Currently, the price is at 70 euros per ton of CO2, projected to rise to 125 euros per ton of CO2. If we do actually reach that price for CO2, I think a lot of other industries will become more interesting for CCUS. So I'm talking about the steel industry, the cement industry, coal and gas-fired power generation. I think these all then fall within scope. Also in the US, we've got tax credits. So I think it's about $85 per ton of CO2 from industry and power generation. And for direct air capture, you currently, I think, get $180 per ton of CO2. So those, of course, quite attractive economics that can make a business case work. In Europe, direct air capture will be integrated into the ETS, hopefully, starting from 2028 up to 2030. We'll see how that impacts the ecosystem. But of course, it will create a financial incentive to implement both direct air capture and point source carbon capture technologies.
One just point to add on the direct air capture side, obviously direct air capture, because it is potentially standardized new facilities, there is actually more scope to drive down costs through a kind of standardization and kind of repeatable factories than a kind of point source on existing facilities. So there's also that angle that the kind of most standardized part of the CCUS story may well be the direct air capture part.
Yeah, and funnily enough, we're also seeing some direct air capture technologies being implemented for point source carbon capture. So we have a portfolio company called Repair Carbon, and they initially set out to capture CO2 from the ambient air, but they've received a lot of interest, for example, from the aluminium industry, who have very dilute CO2 concentrations in their off-gas. So, yeah, it's interesting to see how sometimes startups or scale-ups start pivoting to applications and industries where the imminent potential for their technologies is simply greater. So I'm hoping that a lot of direct air capture companies that are maybe somewhat struggling with direct air capture per se, because the market has lost a bit of momentum, will be able to bridge this, let's say, downturn in interest with point source carbon capture projects.
That's good. Yes.
So maybe a couple of points while we're talking about cost and things. So personally, I wouldn't be having direct air capture as some of my early cap projects because they are just, in absolute terms, the most expensive. I think the best thing to do is to use some of this heavy industry stuff first to bring a bit of critical mass and get it going. But then you have, as direct air capture costs do come down, they become more competitive to sort of fill up the infrastructure. But I think a couple of other things on cost. We talked before about financing. In order to get this thing over the line, the actual assumptions that sort of plugged into our business models were very conservative to help people really get comfortable with what they were getting into. Actually moving your assumptions from a highly conservative to a more sort of P50 kind of approach actually unlocks more capacity.
Yeah.
And if you like, the unit cost of what you're doing starts to go down. So instead of building infrastructure, in our case, say, to store 100 million tons of carbon, the same infrastructure could readily store 150 or 200 million. But in order to do that, we need to bring familiarity and get people comfortable with that. What I would expect future deals to do, therefore, is as financiers and insurers get more comfortable with the technology, understand how these value chains lock together, the risk premium they're building into their numbers will start to come down. So we should see over time financing costs also come down.
That's like you will say like you are the early adopters of the technology.
I would definitely say.
You're doing the hard work for everyone else. That's great.
Yeah.
Since we are talking about costs, there is a question from the audience that asking you to talk about the cost to concentrate and dry the CO2 before storage. Does anyone of you want to pick up that question? Can you talk about the cost to concentrate and dry the CO2 before storage?
I can't. It's more from the capture project.
Yeah, I can talk a tiny bit about that. So the costs of, so there's a handover between the capture plant and the TNSCO, which happens at a particular point above ground installation. So we have to capture the CO2 and then we have to condition it. So we have to get it to the right temperature, remove water, remove contaminants, and then we can inject it into the TNS network. There are some costs of compression, but they're not massive. The biggest cost comes from the capture. There's a lot of energy required in capture because you're heating up and cooling down flue gases. So most of the costs are in capture. The conditioning, concentrating it down and compressing it is not a massive element. Linked to that, though, I think the economies of learning and the economies of getting a de-risked solution over time will be a factor in capture. So we had to build quite a high-performing spec to meet the requirements of the government business model, to meet the requirement of the TNSCO. So it was a very, very high bar, and to get all stakeholders and lenders comfortable. So we've designed something which is a very, very high performing asset. In the future, you might be able to design something. So we've built a Ferrari. You might be able to build a transit van in the future.
Yeah.
So costs could come down because some of the requirements from the government business model, from the TNSCO, some of these things. So I think in capture, you could expect to see some economies of learning, economies of just shaping the performance to be more suitable. On the transport side, the real secret is having pipelines. The best way to transport CO2 is in a pipeline. If you have non-pipeline transport, it becomes much more expensive. And CO2 has a particular feature, if you're used to transporting methane or water around, that always stays in the same phase. CO2, if you're changing phase, so if it goes from gas to liquid or from liquid to dense phase, every time you change phase, there's a tax, you're paying a cost, an energy cost of changing phase. So if you start off in your capture plant with a gaseous pipeline and then you have to liquefy it to put it on a train, and then you take that to a ship and you increase the pressure again, and then it goes into dense phase. Every time you change phase, that's a big cost. If you can keep it in one phase in a pipeline, that's the cheapest way. So in the future, if we can get economies of scale and learning from capture, but if we can also design fit for purpose capture plants, and if we can get pipelines, that could drive the cost down.
Perfect. And in terms of like storage, I assume that, but probably I'm very wrong, but I assume that the preferred option is to store it in like natural reservoirs, like usually depleted gas fields and so on. First, like, is that true? Is that the preferred way of storage it? And second, are we going to run out of storage places when CCUS is up and running?
Take that one.
Yeah.
I'm very well aware I've got one of my regulators in the room as well. So actually what the UK is doing is a bit of a twin track approach. So as Andy said, there are two clusters that have actually gone through FID already in the UK. One in the northwest, which is injecting into depleted ex-hydrocarbon fields in Mersey Bay, and ours, which is injected into a virgin saline aquifer, so just basically filled with salt water. Both have their pros and cons technically in terms of understanding how to manage them. And I think it's actually quite a wise move from the government to try both, if you like, to sort of learn by doing in both kinds. To give you some numbers, broadly speaking, the UK produces somewhere between 400 and 450 million tons of CO2 a year. We have the potential to store readily up to 100 million tons per year, depending on the success of various ventures around the North Sea. And potentially, the number the government quotes is that there is up to 78 billion tons of storage capacity, total storage capacity. Now, that is an up to number. But even if you say, to give you another idea, if you're going to meet our sort of targets for net zero 2050 and import quite a slug of European CO2, which is another business opportunity that the UK stands well placed to benefit from, you're still only storing 2 to 3 to 4 billion tons in that time. So there is plenty of excess capacity in the UK for many, many decades to come.
Yeah, just answer my question. I don't know if anyone wants to add, but yeah. And in terms of like, you just mentioned pipelines as the best way to transport carbon, sorry. And are those pipelines the same pipelines that transport usually natural gas? They can be retrofit to transport natural gas?
They could be. They absolutely could be, yeah. So we've got a national transportation system, which is high pressure pipelines, which is shipping methane around the country, and in 20 years' time, it won't be shipping as much methane. They're generally more than one line, so you could put something else in there.
Yeah.
There's no reason why they couldn't be repurposed.
Well, probably like corrosion issues or
Yeah, there are ways to treat pipelines.
Yeah, it's a very similar technology.
Okay.
You can reuse them. Equally, typically, as we're talking about, the pipeline is such a good way of transporting CO2 that in a project, it's a very low proportion of the cost normally between the capture and the store.
Okay.
So it may well pay to run a pipeline to where you want it rather than try to repurpose. But you can do either. It's whatever happens to work. And, you know, we're seeing there are places with high net where it really works really well. It wouldn't work for the Peak District because there isn't a suitable pipe. So, yeah, it's horses for courses.
Perfect. And there are more questions coming from the audience. Where does BECCS bioenergy with CCS fit in the array of CCS options? And yeah,
I can come on in that if so. We looked at this in quite a lot of depth because it's obviously one of the areas that comes up a lot. So when you look at what does the electricity system need, and can electricity generation from bioresources play a significant role, there are a couple of different considerations you want to think through. The first is the electricity system is where those absolutely spectacular cost declines we've seen from solar, and also to a lesser extent but still very significant declines from wind, play in. So we have some really cheap renewable technologies that are at play for electricity generation. So that does mean in that sector you're competing with some pretty low cost options. That said, clearly a system, it's not just about producing the electrons, it's also about making sure we have them when we need them. Not just when the sun is shining and the wind is blowing, but when we need to consume them. And so there are some that say, okay, well, BECCS is going to be really important for providing some of that, firming the power supply, making sure it's always there. It might play a role, but there's also other technologies like batteries, demand side response. So there's other options in that technology set that might come into play. And for BECCS, you have a competing challenge that truly sustainable bioresources, that means bioresources that when you grow them, you don't inadvertently create more emissions. So that would happen, for instance, if in growing your energy crop that you were going to use to burn in your plant, you displaced a standing forest that already had tons of carbon locked up in that land. If you change the use of land, you can quite quickly get very long carbon payback periods for those resources. So we have to be really careful about using bioresources for emissions reductions. And also you have to be really careful about not competing with land for food production, which is also obviously an important human need. So all that's saying, actually, when we look at it in the round, we don't see BECCS for kind of baseload energy production as a massively significant technology going forward. However, what we do see is, given that we're not moving fast enough, we are going to need carbon removals at scale, and one of the options for carbon removals is actually burning the carbon and storing it, which is a version of the waste to energy example we have here. Where you can add carbon capture and then go and store the carbon from a plant which has had sustainable bioresources, you get negative emissions. And from a system perspective, because we're not going fast enough to be anywhere close to the Paris Agreement well below 2, we are going to need negative emissions. So I would actually shift it. It's not that we can see a really big role for BECCS in the power system, but we can see a really big role for bioenergy with carbon capture and storage to provide negative emissions. So it's a slightly different way of thinking in the system, but it's still an important role.
That's perfect. Yeah, you convinced me. Max, probably this one is for you. Is there any a credible role for private equity in CCUS?
It's a tricky question. For someone like me, I haven't worked in a team myself, so if anyone from the audience wants to volunteer, I would say at this stage, not yet. I think we've still got some work to do in terms of de-risking technologies and successfully pulling off the first few projects. But once something becomes repeatable, I think that's maybe when PE might find this interesting. But right now, I think it's still, technologically speaking, maybe slightly too early. I mean, the technologies are de-risked, but they have to be implemented at scale, and the economics have to work.
I should say, though, I mentioned before about our first projects attracting significant project finance, and the appetite was very much there. So our listings were very much oversubscribed in terms of what the markets were willing to put in because of the nature of the business models and how well they hung together. But obviously the investor will continue to mature, but right now there's a lot of appetite.
That's great to hear. And I want to ask you like one final question to all of you, because we are running a little bit out of time now. Since you have just said, Rich, I thought one answer to my question was going to be the more prominent one, but now I'm open-minded, because I wanted to ask you what was the biggest obstacle to scale CCUS at the moment. Is it like lack of financing, which I suppose it was going to be, or is it policy inconsistency? Is the lack of a proper carbon price, like a high enough to scale this? Is public opposition, or is lack of interest from the heavy industry, for example, what is going on in hydrogen, like no one wants it anymore?
You ask me?
I ask all of you. So each of you, if you can say something. No question.
I'll go for so from our side, all of the above are issues that have to be faced. But I think we have to recognise that getting CCS going in the UK does require government subsidy. And therefore, that government subsidy is competing for your marginal pound against all the other things that government is trying to do. So government is looking at us with affordability challenges and value for money challenges. What I would say, though, is we shouldn't fall into the trap of thinking of this only as decarbonisation, only as net zero. To give you an example, with ourselves and our sister project, the first emitter, Net Zero Teesside Power, we're putting about £4 billion worth of contracts into the market, of which 50% are UK-based. So this is also about jobs, both locally in the area of the clusters, but also nationally with different skills and different things being called upon. The one thing I have asked government is, what would really unlock this even further is a long-term funding profile, to say this is our aspiration, which is, if you like, immune to political changes of wind, that says this is the funding we're making available, so supply chains can actually take risk and invest in that profile, develop the plant, the equipment they need, and develop the skills in the people.
Any of you would like to comment on that as well?
Well, I'd build on it. I agree a lot. And I was thinking a little bit about this, and we have so much of what we need. So we have technologies. Yes, we've got to scale them, and we're deploying some of them in a slightly different context, but it has been done elsewhere. You know, as you were saying, 10 years ago, this was always tomorrow.
Yeah.
Well, you know, it's being built today, and we have a pathway for future. And for me, one of the key things that we've got to do to get to scale is to move, particularly that sort of the economic model, the economic contract, if you like, but the economic model from bespoke, first of a kind, with a lot of government support and hand-holding, to an industry that works, that people can connect to easily, and can get that long-term kind of view of life. So I think we, shining in other people's glory, have done a huge amount to get this off the blocks and get started. There's another phase to go now, which is about making it more routine, systemised, and less bespoke. And I think that's the big challenge that we're facing at the moment and working through.
Well, I must say that after this panel, I am much more optimistic than I was just before on CCUS. So thank you very much for all your explanations, your comments. It has been very enjoyable. So please, let's give an applause. Thank you.